Okay, example problems for, what section are we in? 3-5, day 1. Here's the deal. Hopefully you didn't skip this video because there's a little twist in these just to make your lives a little more complex. So, problem says, what are the zeros of this function? If you look at the previous examples on the pre-lesson, this is factored for you. So there you go. It's like, oh, dang it. Factoring, it's not going away? No. All right, so here we go. Step 1, step 2, step 3, step 4. I got a few examples for you. Not going to explain them all this time, just going to do them. So they're not that hard once you do a few of them. So step 1 on this one is actually factor it. So that'd be the same thing. Take an x out. I'd be left with x squared plus 2x minus 3. Now wait, is that factored? No. So x, this is a gotta one. So now I know it's going to factor into two binomials, x plus 3 and x minus 1. So now I can identify my zeros. So this one's going to say 0. That's going to be -3. This one's going to be a 1. So if I go to my graph, 0, 1, 2, 3, -3, and 1. There's my zeros. All right. Now the next thing I'm going to ask, is this an odd or even? And is the leading coefficient positive or negative? We're going to put all these together and get what I've been referring to as the chocolate wafer part of the Oreo cookie. What's happening from here and here? Does it go up? Does it go down? Does this go up? Does it go down? So if we look at this, this is actually easier to answer now because all I have to do is look at this term, the highest powered term. So that's an odd, specifically a cubic, with a positive leading coefficient. And if you remember, the general rules for a cubic are that right there. It's just, that's the graph of a cubic function. So we're going to take out that part. All we need is the end pieces. So we know that goes up that way, that goes down. Are those accurate? No, but it gets the Oreo cookie part. Now we have to consider what happens at these zeros. Does it bounce or go through? Well, if you look at this, this is a 1, this is a 1, that's a 1. So all three of these, you're going to have this graph pass through. Accurate or not accurate? Not accurate. So now we have to plug in the halfway point, so that'd be f of 0.5. And then this, unfortunately, because that's a 3, is also another decimal, but that's a -1.5. I'm not going to take up this space. I'm going to do the math, and then I'll show you. Okay, so I plugged in 0.5. Now, one thing I wanted to show you guys is on the red part, plugging in 0.5, I just plugged it into the original. And so just to show you, you can do both. And then I got -0.875. When I plugged in the -1.5, I actually put it in the factored form. Whatever you think is easier, it's the same thing. And I got 3.375. And this makes sense because at 0.5, it's supposed to go underneath. And that looks pretty accurate. So I'm going to keep it. You know, if this is 1 or -1, I was lucky. And then 3.375, 1, 2, 3, 4, you know, that would be right about here. So that would come up, come here. So that's actually not accurate. And there's a really good accurate drawing. All right, 2 more samples like that. Okay, slightly different. So it says, what are the zeros of this? And I didn't put that, but and graph, sketch. So we look at this, we're like, uh-oh, it's not completely factored. So you're like, hey, difference of 2 squares, x minus 3, x plus 3. Here, that's a perfect square trinomial. So that's x plus 2 times x plus 2, which if you were to write it like they would write it like that, which is very important to see that that is an even number. That's telling us it's going to bounce off that 0. See how we're getting better at this? And it's going to go through that 0, and it's going to go through that 0. So what are my zeros? 3, -3, -2. So if I take a second, 1, 2, negative, 3, negative, and then my positive 1, 2, 3, there. Now, we got to take a minute and say, okay, is this going to be an even or an odd powered problem? So if we look at this, x squared, x to the first, and x to the first, I get x to the fourth. There's your algebra 1 stuff, okay? So now we know that our leading, so again, there's a positive here, a positive here, and a positive here, and there's no negative here. So this is an even number, so it's just like a parabola. The rules are the same. The graph's totally different, but all we care about is the extremities. So we know it's going to go up from here, and we know it's going to go up from here. Now we're going to work our way in based on what we know about the bounce, or does it pass through? Remember what we said. We said it's going to bounce off -2. So here's my -2 right here. It's going to pass through -3 because that's a 1. So there's my -3. So it's going to pass through, and then it's got to come up and bounce off here, not going through, but it's going to bounce, and it's going to come up like this somehow. And it passes through 3 because that's a 1. So that's a very poor drawing, and now we're going to attack it with some accuracy. So what's the halfway point between -2 and -3? That'd be -2.5. It's a pain, but you got to do it. Now, this is -2 over here, and this is 3 over here. So, I'm going to put that little slash back in there. That's a total of 5. Half of 5 is 2.5. So if I move left 2.5, I'd end up here. If I move right 2.5, I'd end up at the same place. So that's telling me I got to plug in 0.5 for x. So I got to go f of 0.5. Now, as you get better at this, you're like, hey, that better turn out negative, and this one better turn out negative. So both of these better turn out negative. Let me pause this. Okay? So my halfway point between these two zeros is 0.5. I got to figure out how low that is. So I plugged it in here. You can look at my work if you want to. Pause the video. I got 54.68. I had to use my calculator, of course. Now the halfway point here, -2.5, to find out how low that spot is. Plug that all in. Did my work right here. And then I got -0.68. So this guy barely dips below. So if this is -1, it'd go about halfway and then up. Not looking for perfection. But remember, it bounces off here. And then this is way down there. I don't have space on the board, but this spot would be way down here. So this actually goes cruising down. That comes screaming up probably. So I'm going to fix that. And there it is. And we get rid of our poor sketch. And now we have a more accurate sketch. There you go. One more sample with a little twist. Okay. Here we go. What have we been doing in the previous examples? Well, we try to factor this because it isn't. Try to factor that because it isn't. Then we can read what our zeros are. Here's the twist. This right here should be easy for you guys. You're like, hey, I know that. That's a perfect square trinomial. So that's x plus 2 squared. Now, during factoring, I said it a couple times, but it's not like you guys have been hit with a ton of factoring. So if you guys saw x squared plus 9, I bet you some of you would try to make that x plus 3 times x plus 3. But if you actually FOILed that out, you get this, which is not the same as this. And like I said, a sum of two squares is not factorable. Now the previous example, it was x squared minus 9. That's a difference of two squares, so I want x minus 3, x plus 3. That's good. Now what in the world's going on with this? Well, here's a twist. Okay. If that's not factorable, and I think, okay, because my next step is to determine what my zeros are. Now, I'm not making this hard just because, but I go, hey, x plus 2 is 0. Subtract 2, x equals -2. I would never do that because we've done 10,000 of these. I could just look at that and say, hey, it's -2. But what I'm saying is, I would do the same thing for this. And I'd subtract 9, I'd get x squared is -9, bada boom, bada bing. I go, wait a minute, that's plus or minus 3i. There are no imaginary numbers on the x-axis. So guess what? Strange, but this is part of my graph, but this doesn't give me any zeros. So this is my only zero. So I would go to my graph, 1, 2, and I then have to make a determination. Like, okay, where does it go? Well, remember, we're going to say, is this an even or is this an odd degree polynomial? So if I looked at this and I multiplied this all out, let me pause this a second. Okay, I had to take care of something really quick. So to determine, is this an even or an odd polynomial, all you need to do is go back to the original and look at these two highest powered terms, multiply them together. I get x to the 4th, so I know it's an even powered term. Also, no negative, no negative, no negative. We haven't had one like that yet, so it doesn't look like they're going to get after you with that yet. But that would flip the graph, and then the end behavior changes, but don't worry about that right now. So this is related to this, which is a parabola, so we know the end behavior is going to be like that. Well, here's the thing. We only have 1, 0, and notice, because of that 2, it's going to bounce off the -2, 0. So we only have one thing to do, up and up. Now, because it's x to the 4th, it would probably actually be a lot skinnier because it would go up a lot faster. But we're not looking for perfection, just getting the general idea. So I think you guys are ready for just a few of those homework problems that help you practice this.